Let us study components of a vector. Let us take point A 1, 0, 0, B 0, 1, 0 and C 0, 0, 1 on the x, y and z axis respectively. Then clearly we can see that OA vector mod equals to 1. Similarly, OB vector mod equals to 1 and OC vector mod equals to 1. The vector OA vector, OB and OC, each having magnitude 1, are called unit vectors along the axis OX, OY and OZ respectively, and are denoted by I cap, j cap and k cap respectively. Now consider the position vector OP of a point P x, y, z and let P1 be the foot of perpendicular from P on the plane XOY. We thus see that PP1 is a parallel vector to z axis, as I cap, j cap and k cap are the unit vectors along x, y and z axis respectively, and by the definition of coordinates of point P, we have PP1 vector equals to OR vector equals to ZK cap. Similarly, OP1 equals to OS equals to YJ cap and also OQ equals to XI cap. Therefore, it follows that OP1 vector equals to OQ vector plus QP1 vector, which is equal to xi cap plus yj cap. OP vector equals to OP1 vector plus PP1 vector. Hence, the position vector of P with reference to O is given by R vector equals to xi cap plus yj cap plus zk cap. Here, x, y and z are called the scalar components of R vector, and xi cap, yj cap and zk cap are called the vector components of R vector along their respective axes. Sometimes x, y and z are also termed as rectangular components. The length of any vector R equals to xi cap plus yj cap plus zk cap is readily determined by applying the Pythagoras theorem twice. We note that in the right angle triangle OQP1, OP1 equals to under root of OQ square plus QP1 square, which is equals to under root of x square plus y square. And in the right angle triangle OP1P, we have OP1 equals to under root of OP1 square plus PP1 square, that is equals to under root of x square plus y square plus z square. And hence the length of any vector R xi cap plus yj cap plus zk cap is given by mod of vector R, which is equals to under root of x square plus y square plus z square. If A vector equals to a1 I cap plus a2 j cap plus a3 k cap and B vector equals to b1 I cap plus b2 j cap plus b3 k cap, then we have following properties. A vector plus B vector equals to a1 plus b1 I cap plus a2 plus b2 j cap plus a3 plus b3 k cap. A vector minus B vector equals to a1 minus b1 I cap plus a2 minus b2 j cap plus a3 minus b3 k cap. A vector equals to B vector. This implies that a1 equals to b1, a2 equals to b2 and hence a3 equals to b3. Lambda times A vector equals to lambda a1 I cap plus lambda a2 j cap plus lambda a3 k cap, where lambda is the same scalar. Let A vector and B vector be two vectors and k and m be two scalars. Then we have k times A vector plus m times B vector equals to k plus m times k times ma vector equals to m times ka vector equals to mka vector. K times a vector plus b vector equals to k times a vector plus k times b vector.